especially since Lynn is not here. Sorry, Lynn, feel better. I don't even know if you'll watch the video. But we want to take as much time as we need to review all or any of Chapter 5. So starting in Section 5.1, did we have any questions remaining from that homework or the notes or anything? And this is also a great time to organize your homeworks and everything in order and then potentially even staple them together. So 5.1, again, was, did we do G or K for that one? Yeah, we may have done K for the whole chapter. Sometimes I like the G's better. There's not really a big difference between them. Oftentimes the G has a few more questions. Sometimes, though, the K has more questions. So it's really, the G is the got it level, the K is the keep going. Like, there's two different levels of problems, so we kind of go back and forth. So polygon, angle, sum theorem. I would write 5.1 right up here.
Hey, I already did that.
Yeah, so you know it is. Any questions from that? Yeah, Rhea.
You said you'd go over 23 in class. You did say that. Yep.
Wait, Mr. Hudson.
Didn't we?
No.
I swear we did.
I don't.
Then I discussed it with
You
somebody.
talked to it with me. You talked to me about it, but then Rhea had the same question, so you said you were just going to.
Okay. So let's talk about number 23. The measure of an interior angle of a regular polygon is 4 times the measure of the exterior angle of the same polygon. What is the name of the polygon? So, Carmen and I worked through a way to solve this. I mean, there's many different ways to solve this. But Ethan and Brian, you just raised your hands. Like, what'd you draw? What'd you think about? What'd you do to figure this out, Brian?
I just figured out what angles it would be to be 4 times, and the 4 times the measure of the exterior angle, and just went through the gun until I found it.
What do you mean? Just figured out the angle? What relationship did you think about them needing?
It was a long time ago, so I don't know.
So what are your angle sizes, or what polygon did you end up saying?
I ended up with a tangent of a decagon.
A decagon? How'd you figure that out?
Trial and error.
Trial and error. Ethan, do you have a better method? So, when we think about the interior angle, is that the angle coming out from the middle or the angles around the outside of the shape? Like that middle part? So, if we start thinking about things like this, you're talking about this as the interior angle, and then there's a polygon, whatever, however many.
No.
You're talking about this, right? Well, the whole thing.
Yeah.
Yeah, just verifying that we are all. So when we think about an interior and an exterior, if I draw, let's say, kind of hexagon. So we're saying that this is the interior angle, and then this is my exterior. Or the other line coming off. So what do I know about them? Yeah, they're supplementary, right? So that vocab is helpful to kind of like say things easier. So what I know is that there's a relationship between angles where we have, so it says the measure of the interior is 4 times the measure of the exterior. So if the exterior was x, then the interior has to be 4x. So really what we're saying is 5x has to equal 180.
Excuse the interruption. Could I have Hannah Dolan to the office, please? Hannah?
So if 5x equals 180, we can divide out. I know that x equals 36. So if that tells me that my exterior angle is 36 degrees, then that can let me derive that my interior angle has to be its supplement. So it'd be 144, right? Now, we know this is not going to be a hexagon. So I'm just using this as a reference model. We need to figure out how many sides are actually on that polygon. Now, if I think about these triangles that form from the center of the polygon, the number of triangles tells me how many edges it has, right? The number of triangles tells me how many edges or what the end of my n-gon is. So if I wanted this angle, how would I find that in that triangle that comes out of here like this? Carmen?
You would divide, like, so if it was, like, six-sided, you would divide 360 divided
Ooh,
by...
not this one. That'd be for this.
No, yeah, and then I'm saying you solve that one, and then...
Okay, but that's if we know how many sides there are. We don't here yet, but we do know that that interior angle is 144. So remember
Oh, they're
that...
like... Oh, yeah, okay.
Go ahead. If you know it, go ahead. This angle really continues on, like, so in the triangle it would only be half of it, but if I look at both base angles of the triangle, each of those would be half of this 144, so together they are 144, which tells me that this angle right here has to actually be 36. The exterior angles of your polygon measure the same size as the angles coming off your center point. And if I know that each of these center angles is actually 36 degrees, how many triangles would it take to get all the way around? 10. And that's how we can derive that it's a tengon. Now, when I worked through it with you, Carmen, my brain was in a different place based off what I've been teaching and everything, and I think we worked through it a harder method, but there's a lot of ways we can do this. But the easiest is set up a polygon. It doesn't have to be the right polygon. Just set one up and make sure you don't do anything based off 6 sides. We did nothing here based off it having 6 sides. All we did was set up a relationship, set up an equation, solve for my unknown, and then plug it in and utilize it. So this would really be a tengon or a decagon. Other questions from 5-1? That's really confusing. So, in case somebody only looks at the notes, this would be confusing. I might as well write 360 divided by 36 equals 10. Yay! All right. Nothing else from 5-1? 5-2. Did we do G or K?
G.
Any questions? Check it all over. Make sure you understand it. Michelle?
Proving that a quadrilateral is a parallelogram
Number
number 20.
20. There we go. Wait, this?
No.
Are you sure you're on 5-2? 5-2 is properties of parallelograms.
No, it's a packet. So I'm totally mad.
Anything else from 5-2? I believe what you are asking about, Michelle, is 5-3.
Yeah.
Is that G or K?
That's
G. Anything else from 5-2? We still got it up. I would label this 5-2. Ethan?
25.
Developing proof. A rhombus is a parallelogram with 4 congruent sides. Write a plan for the following proof that uses side, 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 and a property of parallelograms. So it tells me AC and BD, get away. Tells me that AC and BD are intersecting at E. They're the diagonals. We also know that they bisect. But what we need to prove is that they're perpendicular to each other. We need to prove perpendicular. So one way that we could prove perpendicular is proving right triangles. But we don't have any lengths. So that would be kind of tough.
kind of do.
Hmm?
We kind of do.
What do you mean?
Well, since it's a rhombus, all of the outside edges are the same length. And since the diagonals bisect each other, the two halves of each diagonal are congruent.
Yeah, but we don't know
Aren't
any
we trying to
physical
prove-
lengths.
we don't-
Like you could say congruence, but I mean like trying to use a right triangle theorem.
Wait, aren't we trying to prove that it bisects?
Yeah.
So we
No.
can't use the bisect.
No, we're trying to prove they're perpendicular. And because they tell me it is a rhombus, we know it bisects. So when they tell us the shape, we know the properties of the shape unless it's one we're trying to prove.
So why does it say prove AC?
It's perpendicular.
Okay. That makes way more sense.
Yeah. Now it says, for congruent sides, write a plan for the following proof that uses side, side, side. So that's your clue. So if we relate that BE and ED are congruent, and I think my smartboard's slightly off. I have not oriented this year, which is crazy. And EC and AE are congruent. And then we also know that BC is actually congruent to AD. So, what can we see?
Oh,
What else? I actually have not notated everything yet. Part of a rhombus that makes it more than a parallelogram.
Well, because of the side thing, and they share like the same sides and stuff.
There's something else I should notate first, though. You're right. You're on the right track. Straveler?
Because the diagonals are perpendicular.
Ooh, we can't say that because we're trying to prove that.
Oh, that's right.
But Carmen was about to hit on what else I should notate. These
Yeah.
are also congruent. But I didn't notate it up here. Now it can really, like, your eyes should be able to just, like,
So now.
blue, red, green, blue, red, green, blue, red, green,
so
blue, red,
now-
green.
Can I say now?
Now,
Okay, so now because of side, they're all like congruent triangles.
so based on side, 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 they're all congruent. And from there, it says, and a property of parallelograms. But I wonder if the property of parallelograms they wanted was that they bisect.
Yeah, let's say that's one of the theorems is the fact that they bisect.
So, but that still doesn't prove that they're perpendicular. We've got congruent triangles, great.
I'm looking off of the way I did it. I said that I used the fact that adjacent angles in a parallelogram are supplementary.
Ooh, adjacent, so,
Mm-hmm.
you mean it, the interior?
Yeah.
These adjacent or these adjacent?
If you took out the diagonals,
I took out the dot.
like,
So you mean like this whole angle here
yeah,
and this whole angle here.
yeah.
Okay. So where'd you go from there?
The diagonals of a rhombus bisect the angles.
Okay.
So, try to figure out what I wrote.
So if I wanted to color code this,
Okay.
I'm only going to color code for what you are saying. I just need more screen. So what you're really trying to get to, since you said the bisecting part, is that this equals that, and that this equals that, and that this equals that, and this equals that. If you use the same color and put the arcs in different places, we normally infer that we're talking about the same sizes.
And since they're equal, if the whole angle plus the other whole angle is 180, then half of it plus the other half is 90.
Ah, so, and guys, there's different ways we could work our way to this, but what Calvin is saying is if I know that both blues and both reds are supplementary and they make 180, and they're also congruent pairs, then one blue and one red have to be half the 180, which is 90. Now, the other way that we could approach this, like which from there, then the remaining angle has to be 90, and we have our proof. The other way we can approach this, back when we had our red, I think red was single, blue, My colors are probably off, but bear with me.
I think you actually do the same thing.
No, you do the
Sweet.
same thing.
Good for me. What else do I know about quadrilaterals or any polygon to begin with? So I already notated that we have congruent triangles. So by CPCTC, we know that all corresponding parts must be congruent. So really quick before we come to you, I could notate that this angle and this angle and this angle and that angle must be congruent to each other because they're corresponding parts. Do you know where I'm going from here?
Is it, wait.
So let's say that each of these is
I was
x.
thinking the 3, 6, does that work, right? Yeah, oh, okay. The 360 divided by 4.
So really, 360
Or
equals 4x. Because these angles, my interior angles, well, my center angles, have to be 360. And then I can know that they're congruent based off my CPCTC. And then I can just figure out that x has to be 90. So there's a few different ways that we could work our way to here. If we use this method, we don't need to care about the other angles. If we use the angle method, we actually don't need to care about the side lengths. So there's one using the lengths and one using the angles. But your method, I don't know that it necessarily uses side, side, side. Because if you use side, 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 we don't have to notate the angle bisectors and all that stuff. Yours is totally fine. I just think you did more than you have to. Does that make sense? Okay, question?
What's CPTC?
Corresponding parts of congruent triangles are congruent. So if we've already notated that BCE is congruent to DAE, because we have to go in the right order, so I went green to blue, then I know that this angle, my third angle E, would be equal to my third angle E. Or like CDE and ABE, same there. The corresponding parts have to be congruent, so I know that they are all the same size. That makes sense? CPCTC is a very important theorem to remember when you're working with triangles. Ethan?
I'm confused on how we would write out everything you just said in a proof.
I knew someone was going to make me do this. Guys, no one likes proofwriting. It's fun. Like, the process of discussing it and figuring it out, that's really cool. But writing it out, I know it's a little bit more strenuous. So we could say AE, and remember that inner point is E, is congruent to EC.
I have it all the way up to the part where it's like all 4 triangles are congruent.
Yeah, so do I need to list out all my congruent pairs?
No, you don't.
Okay, so I make all those congruent statements because we have to make those statements for the proof to work. Then I would relate triangles. So I'd say, and this is where order gets really tricky. Triangle ADE. I've now chosen, I'm going green to red, is congruent to triangle. I have to go green to red, so I could say CDE is congruent to triangle. I have to go green to red. CBE is congruent. I have to go green to red. ABE. So I'd make that congruent statement relating by side, side, side. So I could have out here said by side, side, side. Cool with that.
Yep.
Then by CPCTC angle E, or sorry, angle, might as well do this one first. AED is congruent to angle DEC is congruent to angle, do you see where I'm going with this? CEB is congruent to angle BEA, and really those are all just angle E's, but that's the problem, is I can't just say angle E because I don't know where I'm talking about then. So we know these are all congruent. Then we could say by, I forget what the specific theorem is called, but it deals with polygon sum or polygon interior sum. I mean, especially for me, you can really just state what you're trying to say. So you could say, based off the central angles of a polygon summing to 360, and the central angles all being congruent, 360 would equal 4 times E, or whatever you want to say here, and then you divide by 4 and you get your 90 degrees from there. Does that make sense? Do I need to write out more of the...
I did a 2-column proof.
Which, yeah, I mean, any paragraph proof can become a 2-column proof, and vice versa.
I'm still kind of confused on how I would write that out. Like, I have the CPCT first, and then I get confused after that.
So you'd like make this statement in your left column, and then your right column justification would be side, side, side.
Yeah,
Right.
I have that part.
Okay,
and I
so
have
then we'd
that-
make this statement and say CPCTC. Then we could say, so really we could say that since these are all congruent, and crap, it didn't stay together, we could say these equal like x degrees, or make it something that you can reference easier. And then you could say 4 times x degrees equals 360, and that, stop flashing, I see you. Are you kidding?
You have to open up the new windows.
It's annoying. So that could be by like polygon central angles, or whatever you want to call it.
Interior sum theorem.
Interior sum theorem. There we go. Whether that's actually it or not isn't really a big deal, as long as you can communicate what you're trying to say. So then, through division property of equality, I get that x equals 90, and your reason for that would be the division property of equality.
The depot.
The depot.
That's what Mr. Hall. That's
Yeah.
the only reason I remember.
The Home Depot.
And then
Depot to Espo.
we've proven they're perpendicular. So then you can make your perpendicular statement of BD is perpendicular to AC, and your reason for that could be they meet at a 90-degree angle. Does that make more sense now? The only thing I'm not writing is the last step because I've run out of space.
Yeah, I think I got it.
Real or no? I honestly think paragraph proofs are easier because you just kind of like, it's stream of consciousness. It's like, what do I know? Just start writing it. Sometimes it gets a little messy because if I like change something or decide to do something in a different order, that can get a little hairy, but I like paragraph proofs. Anything else, 5-2? Yeah.
Just not the same question. I'm just asking. So just making sure. But if we just said that rhombus ABCD is like a quadrilateral, has 360 degrees, and the interior angles would equal 360 degrees, could we just write like that, and then 360 is equal to 4x?
You can't unless you make the side, side, side statement first. Because you don't, even if you know that they are 360, you don't know that they're congruent. To figure out that they're congruent, we have to relate the triangles first. Then we can say what you said. Does that make sense? Because knowing that they, like, think about if this was a rectangle. Because they don't necessarily, like, it could be a square, and they could be congruent, but it wouldn't have to be, and it uses the same 360 sum of those angles. All right, 4-3. Did we do G or K on that one? Or 5-3, sorry. G or K?
G.
G. Carmen.
Number 10. I said no.
Can we prove that the quadrilateral is a parallelogram based off the information? Do I know anything about side lengths?
No.
Do I know that my lines are parallel?
No.
Do I know anything about congruence except for those angles?
No.
It seems like a whole lot of no's. Megan?
Wouldn't you know that the other two angles are also congruent?
No.
We would only know that if I knew that these were parallel.
Oh, we're talking about those.
Yeah. So because I don't know any of this, and I don't know any of that, like I don't know anything else, we don't know anything. Because this, well, is a parallel.
See, I was wondering if you
Can
buy
We
those
might
side
be able to
lines.
make it work.
Wait, can I come up and draw something?
Yeah, I'm trying to think here for a
Like
second.
because of those side lengths being that would then I don't know. That's
Because those angles are congruent.
It can be disproven. Right?
But then that would mess up the other two angles.
Hmm.
Oh, I was right.
Because as soon as I change one of the distances, without put it flat, just put it flat on the board. There you go. Without checking the key, I'm not 100% certain, but I think we can. The problem is, how do we get there? Do you know?
Well, adjacent sides are supplementary. And
What do you mean
there's
adjacent sides are supplementary?
Not sides, angles are supplementary.
Why do we know that?
None of those are parallel. What? Wait, are you confusing me or am I?
No, I'm quite frankly confused myself.
It's not saying. Can I?
Emma? What? What's that state?
If a quadrilateral is a parallelogram, then its opposite angles are congruent.
Well, we don't know that it is a parallelogram.
No, we're proving it's
So you're trying to use the inverse of that. So say that louder because I don't think the opposite side of the room heard.
Say it again.
If a quadrilateral is a parallelogram, then its opposite angles are congruent. And then I'm trying to use the inverse of that.
So the inverse of that is if we see a quadrilateral with opposite congruent angles, it is a parallelogram. Because the thing to think about is if if this wasn't congruent, let's say this was longer, that would extend further, and when this would connect down, this could not be congruent to that. Likewise, if this extended longer than this one, then the angle would get larger. So even though we only see two angles here, I'm fairly certain it's still provable by the inverse of that theorem. The other thing to think about is, well, and that's inferring that they're parallel, but I think based off this, they're essentially alternate interior, something like that. Because if we see this angle equal to that angle, and we know that if I extend this line, these would be supplementary, and if I extend this line, these are supplementary, then I really kind of see corresponding angles. Yeah?
But I was thinking, wouldn't the inverse not always be true? Can I draw something?
It's not always true if you can disprove it. Yeah, sure, come on. I'm going to pull up a file really quick.
Oh, I heard flower too. Also, can I draw flower?
Yeah. I'm waiting for you so I can move things.
Context clues.
It was probably okay, so this is supposed to be a kite.
Hey, give Ethan your attention. We're grappling with this.
Is this supposed to be a kite?
That's what I was saying. What if it's a kite?
Like, but wouldn't these be congruent?
And those
are
opposite
Because they're opposite angles, but that's not a parallelogram.
Yeah, valid. I agree with that.
So the inverse isn't always true.
So there's your counter example. Love it. That's a great counter example. These opposite angles are not congruent, but these are. So yeah, that's like, it could be a parallelogram, but the question is, will it always? Does it have to be? And that's what I'm struggling with. I'm trying to pull up the zip file of the answers, but
Well, it says, can you prove it? And if you can disprove it, that means it can't be.
see, that's, yeah, if we have the counter example, it can't work.
Therefore, no, you can't prove it.
I forget where the zip
have to show
answers are.
that the other set of opposite angles would have to be congruent in order to be
Yeah, we'd have to show something else probably.
We don't know
All right, so that one should be a no, but it could be. But we can't prove it. It could be a parallelogram, but does it have to be? Is no. That's where the struggle comes in, is when it could be, but doesn't have to be. Because you could say, well, yeah, because the opposite angles are congruent. And then from there, but that doesn't, because we don't know the lengths. If I knew anything else, if I knew that these were congruent to each other, then boom, I'd have it. Or if I knew that these were supplementary, I'd have it. Yeah.
I don't have a question of the answer, but for number 12 and number 15, they're the same question.
Huh, yeah. That's funny. Yep.
On the other page. Oh yeah, and now
And now 20. It's given that Mo is congruent to TR and NP is congruent to QS, where MNOP and TQRS man, gotta draw a bunch of stuff. Alright, crap. My Zoom is not working out.
Please pardon the interruption. Josh Malik and Ty Hunt to the office. Josh Malik and Ty Hunt to the office, please. Thank you.
So, MNOP. This is that glitch on my smartboard I'm talking about. And it jumped my line up.
Like your little spot.
Yeah, it's somebody. I think somebody hit it too hard. I mean, maybe it was me. Who knows? And TQRS. So we see MO congruent to TR. Congruent to TR. Now, I'm drawing this to look congruent. And then we're going to disprove it. Those statements are true. What do you think?
the way I visualized it was like I had a square. Should I draw?
Sure, if you want.
So I had a square with the diagonals, and then I rotated them so that the bottoms and tops still lined up, but these two angles were smaller and these were larger, so it looked more like this, but they're the same length and it's a rectangle.
Yeah, so rectangle compared to square. I'm just trying to think. Yeah, so like if I pulled up GeoGebra.
What?
Oh, that little thing. Oh yeah, I remember that. At first I thought it was like another like part of math that we had never heard about. It's
Like calculus and trig.
yay.
Calculus, trig, GeoGebra.
Yeah.
One of the cool things that we can do on here
This looks fun.
is manipulate. Have you guys not seen this?
Yeah, you should.
That's what I thought. So if I set
I
up,
just think it looks fun.
I'm gonna make. Well, this is gonna keep it regular. Don't be regular. Be just a polygon. And then you had these lines. What Calvin is saying is if this is a square to begin with, and we keep these lengths fixed, so I could This is going to take too long. Fix object. And I don't know if that's still going to... I haven't used GeoGebra in a little while, so I don't know if it'll fix it. Yeah, so it fixed the lengths, right? The lengths cannot... No, what are you doing? So if this would work with me, I normally prepare when I'm going to use GeoGebra and I practice what I'm going to do. But say this is a square. Then without changing the length of the diagonal, I can bring it down, which would shorten it. But if I bring it out, it would extend it. Same thing with this one to compensate. And those diagonals could still stay the same length and still stay congruent with it being a different shape. Does that make sense? If you rotate out, now you're outside the polygon.
It looks 3D now. Like a pyramid.
But you can actually graph in the 3D plane.
Whoa.
Like, there is a 3D plane. So if you...
We did it again. How did we do that? And how did we do it last time either? Do you remember when Mr. Estes gave us a pop quiz?
Oh yeah.
And they said which is better, Pepsi or Coke? And we all like...
Oh, I don't need to
20
recover.
kids went all like, oh, at the same time.
So if you ever want to graph in the 3D plane, this is fun.
That looks hard.
So GeoGebra is a free Google app. Feel free to get in and play with it when you have time.
So is that like 3 different coordinates?
Yeah, XYZ plane. Instead of just the XY plane. Carmen, what's up?
Oh, no, sorry.
I'm just itching.
I was right.
Any other 5-3?
Wait,
Ethan.
13.
Was that you also, Caleb?
I don't get these at all.
I don't understand these proofs either.
So with 2-column fill-in proofs, you really want to think about what am I missing that is justified by the other column. So it tells me we have parallelogram ABCD with AC congruent to BD, and that's our given statement. We want to prove that it's a rectangle. So the reason for whatever my statement is that opposite sides of a parallelogram are congruent. So wait, opposite sides are congruent. Well, opposite sides would be like those and these. So my statement here would be AB congruent with DC and AD congruent with BC. Does it make sense why that's my statement?
Yes.
So then the next statement is that DC is congruent to CD. Wait, it's the same thing. What is it when it's congruent to itself? Reflexive. Does it make sense why that?
Yes.
Then it tells me side, side, side. Well, okay. That must be relating two triangles because it's side, side, side. So we have a triangle congruent statement to figure out. Since I already talked about these congruent sides and these congruent sides, what two triangles do you think they might be relating? Brian?
ADC and BCD.
Yeah, ADC and BCD. And the next thing you can look at, if you can't figure that out, is what's the next step that they talk about. So if ADC, angle ADC, and BCD are supplementary, that's related from those triangles. So this, what order we say? ADC. And why we related the DC to the CD is to make this triangle statement. Yeah.
Wouldn't it be?
BCD, sorry.
Yeah.
That's why it was DCCD. Yeah, order gets tough with me sometimes. So same side, different order, reflexive. Then ADC and BCD, or sorry, yeah, ACD and BCD are supplementary. How do we get that? What's that go back to us knowing?
If a quadrilateral is a parallelogram, its consecutive angles are supplementary.
So in the given, we were told parallelogram. These angles that it's relating are adjacent angles. So you could, and I hate using theorem numbers, but you could just say adjacent angles of parallelogram. That's really theorem 41 or whatever you said, but I don't really like theorem numbers. Theorem names are way better. Like just calling it whatever you're trying to say. Ethan?
I said SSI. Seems something to
Yeah, it's a parallelogram. Yeah, you can do that because we have parallel sets. Then we use CPCTC. Then the next reason is congruent supplementary angles are right angles. What congruent supplementary angles do you think they're trying to call right angles, Megan?
angle ABC
Angle ABC,
and not ABC,
ADC, and
BC.
BCD? Yeah, because they already said that they're supplementary. Then they tell you that they're congruent. So then what they're doing is pulling both of these statements together to make them right angles. So my statement is really a copy of that statement equal 90 degrees or are right angles. So you could say ADC and BCD are right angles, or you could say equal 90 degrees, but your reasoning is that congruent supplementary.
Number 5, I said consecutive angles are supplementary.
That's like the same thing as same side and adjacent. It's they're all different ways to say the same thing. So you're good. DAB, CBA, DAB, CBA, those angles are right angles. Emma?
Because they're supplementary to ADC and BC.
Yeah, because they are the supplements of right angles. Because we've already proven D is right, so A would have to be the supplement of D, B would have to be the supplement of C. We've already proven them to be right angles. And then what do you think fills in for the reason for definition of a rectangle?
ABCD is a rectangle.
Really, ABCD is a parallelogram with right angles. Because if you look at what we proved, we knew it was a parallelogram. We proved right angles. So we want to use this fact that they are right angles in my final how I tie it all up.
But don't you always conclude it with what you're proving?
Yeah, but you could say that, but you're essentially just defining it there. So if I was doing this, I'm not saying that you have to. If I was doing this, I would maybe add a step that says ABCD is a parallelogram with all right angles, which makes it a rectangle. Now, you don't have to write that much out. I sometimes go beyond. This is why I became a math teacher.
Seems really
Redundant. Yeah.
because we've already
We did.
established that.
Yep. So you don't have to, but I like to tie it all up pretty with a nice little bow on top and say it's a parallelogram with right angles. It makes it a rectangle. But you already know all that, so you could just say,
I think. Mr. Hudson,
yeah,
what does RT stand for?
right.
It looks like
Yeah, we gotta go.
triangles. We
Yeah,
have
I know.
more questions and other homework.
We'll do it tomorrow.
Okay.
We'll start on 5-4 homework tomorrow. Thanks, guys. Have a great day. Yeah, we'll go over the rest of these tomorrow.